Hi, nice to see you again, sort of, conceptually. Welcome back to the next episode of our series on architecture of business applications. As promised, this one will strike at the core of the glamorous buzzword in the architecture space. What is a microservice? So we have talked about service-oriented architecture, and now we need to go into microservices, because if I don't cover microservices, my credibility is mud. Okay. So what is a microservice? Extreme answer to extreme scalability needs. When you want the highest possible throughput, you use microservices. So what is a microservice? You start with an SOA, service-oriented architecture. If you remember, with service-oriented architectures, we talked about how each service is made up of a whole bunch of web services, and that bunch of web services shares one database. So service number 1 may have 75 web services, all hitting one database. Service number 2 may have another 55 web services hitting a second database, and so on, right? So you start with that in your mind, break up each web service call into a separate server, make it a separate service. Each web service call. Replicate the server if required, if you have requirements for a lot of throughput. So you can actually build a cluster of half a dozen servers for one web service call, okay? And each microservice has its own database. So what you're doing is you are dedicating one server or one or more servers, one physical server or one container with its own CPU resources, its own RAM, its own database for exactly one web service call. That's a microservice. And when you have microservices, see, a microservice is doing next to nothing. It can only respond to one web service, right? So it only knows how to do one thing, which means there are no brother and sister services which update any database of its own or provide a full suite of services, which means 99% of the action is happening outside the microservice. This microservice is doing exactly one thing. So where do you get the view of the other 99%? The answer is very simple. Data from other services needs to be replicated into the database of this microservice. So east-west replication, east-west communication using an ESB is mandatory if you want to do microservices. And when you have replication, there will be a slight latency, which means that I do a transaction, the transaction hits the transaction database in real time. Otherwise, the transaction commit doesn't even happen, right? And then suppose I have a reporting server, which is a microservice. So the latest transactions are going to get replicated to the reporting microservice, and then they will show up in the account statement. But there will be a latency of maybe a few milliseconds or a few seconds. So this replication, which is required for running a microservice stack, will introduce a slight latency. It is definitely going to be non-zero. So one of the common examples is show account statement. When I want to look at an account statement, suppose there are typical times of the month where all the savings bank account holders of a big bank want to see their account statement. Maybe it's the beginning of the month, and they all want to see whether salary has been credited or not. So maybe for the first 5 days of every month, there is an enormous load on just account statement viewing operation. So one way of handling it is to carve it out into a microservice, because it's just one operation, right? You are not really doing a service. It's not all the operations related to a bank account. It is just view bank account statement, one operation. So carve it out into a microservice, give it its own database, and let it run. So conceptually, it is part of the accounts service, but it is implemented as a separate microservice. So it is not part of the service stack. It is a separate microservice stack. So it can handle a very high frequency of read-only hits. And if you want even more throughput, you create replicas of the database and you have a whole cluster of servers. Now, I compare a microservice with a very high-end sports car. So you have to understand that a sports car is awesome in performance, but it comes with its costs and its complexities. All the parts are expensive. It's a royal pain maintaining a sports car, not a Toyota or a Honda or a Ford or one of those cars which are sold in hundreds of thousands. So this you'd probably have only 5 of these sports cars in your city, and there'll be only 1 or 2, if you're lucky, service centers who can maintain your sports car, and the parts will be unique. They will have unique shapes and unique constructions, and therefore you'll have to procure them at high cost. And all the things that you do for other cars will probably not be applicable to this sports car. So it will be a big separate headache to maintain a separate extremely high performance stack. So if you need that performance, there is no answer. But when you go in for it, make sure that you understand there is a cost associated with it. So this is a diagrammatic representation of the idea of a microservice. What we have tried to show in this diagram, what I've tried to show here, is 4 separate microservices, not one microservice. Each has one application server where the application code is executing and one database of its own. So this is a picture, this is just a simple conceptual picture to show 4 microservices, one web service in each. Now this is an interesting take on that. The first microservice has been scaled up a little. Database is still 1, but application servers are 3. So what I'm doing now is throwing more compute power at that microservice, because I can see that maybe the code that is executing in that microservice is too compute heavy. So a little more CPU power is required, but one database is good enough. So I'm sharing one database and I'm throwing 3 servers at the microservice. Okay, so this is the microservice picture. Why do you need a microservice and why you should not use a microservice? First, why do you need a microservice? The obvious reason is extreme scalability. There are other reasons. The glamour comes from scalability, but there are other important reasons why a microservice may be attractive in some situations. One of the reasons is partial service availability. If you have your application running on one server, the server goes down, the second server has to kick in and the entire application has to be restored. If you have your application running on a cluster of 15 servers, including 5 microservices, then each microservice can go down and the rest of the application can continue to work. 15 after all, right? 1 out of 15 down is still 14 up. So breaking up your application into multiple servers gives you high partial service availability. The third benefit of microservices is high granularity, fine granularity. So you can bring down one, do some maintenance, bring it up again without the rest of the services being affected. That one microservice will go down, I accept, but the rest of the application won't go down. So maintenance can be done in small pieces, Another reason for microservices is non-technical. If I have 10 microservices, if I have one big server with the entire application in one piece, then one software development team has to manage that entire application, which means the entire team has to coordinate and release patches, bug fixes, extensions at one shot in one release cycle. If I have 10 microservices, then I can actually employ 10 teams and each team can manage its microservice. So I get more scalability of the teams and more flexibility of managing separate release cycles. So this is basically the classic model of the object-oriented software architecture. So that's for the pluses. These are the reasons why a microservice is attractive. What are the minuses? My favorite minus is that I don't like too many moving parts. From a service-oriented architecture to a microservice architecture, I'm just adding more moving parts. So an entire service with 100 web service calls, an entire application service with 100 web service calls may run on one server. If I carve out 2 microservices from there, those 2 will run on 2 additional servers. So I now have my moving parts going from 1 to 3 for a small amount of extra separation. So this degree of separation is something I would rather avoid, if possible. The second problem is the problem which always happens when I have a highly distributed application. The more highly distributed it is, the more of a pain this angle is. Observability and traceability are a royal pain. When I have 100 microservices running on 100 different containers, trying to understand what went wrong where might involve tracing through 15 of these microservices ka separate logs. So observability is a problem. You don't know what's going wrong where because there are more moving pieces to track. Then the third problem is timing and latency challenges in a highly distributed system are very difficult to reproduce. So suppose you start getting complaints that sometimes this particular call is taking 30 seconds. Sometimes. How do you reproduce it? If it's taking 30 seconds every time, you can go and check and there it is. It will be in front of you. Either it is true or it is false, but there are no gray areas. But if in a microservices architecture, there are latency challenges which happen sometimes, it is because there are certain back-to-back moving parts which are either responding slowly or are choking somewhere or are getting into some temporary short-term locks, or there are some resource contentions which cannot be reproduced under testing. So timing and latency challenges are not reproducible. It's not a matter that we have timing and latency challenges. No, you can have latency challenges in a monolithic architecture also, but here they are not reproducible. Fourth point is that it increases latency. This may not be a concern. If you're using a microservice, it means you have factored in the fact that there will be a slight increase in latency and you're okay with that. But just for the record, I wanted to sort of put it in the list. And microservices means cross communication, the east-west communication as we call it, shoots up. Because you're from one service, from one container or one server running one service, you might be going to 20 or 30 services, whatever. So the communication to synchronize all of them goes up 20 times. That traffic shoots up. So your data center backbone had better be fast enough to handle that cross communication. So these are the reasons why you want to be very careful before you get into microservices. But unfortunately, as I said, when the solution to the problem is a sports car, then no Honda or Toyota will do a good job. So when it is genuinely needed, it is needed. We don't know what else you can do. Now we come to this term which I have heard being thrown around several times. Oh, we are building a microservices architecture for our so-and-so application. And I have often wondered what exactly this means. So I have to tell you the story. Okay. No, I think I'll tell you the story at the end of this. Yeah. Let me first explain to you what a microservices architecture is supposed to mean. Okay. So a microservices based architecture means that there are no services where one service has 100 web service calls. A microservices based architecture means that every web service call has its own container, running its own processing and with its own private database. So you might have 500 microservices. That's the only way in which the term microservices based architecture makes any sense. Because otherwise, you may have a service-oriented architecture or a monolithic architecture with 5 microservices in addition. So when you don't want to use the term in addition, then you mean that the entire architecture is microservices. So this is a really extreme situation. I cannot honestly imagine where this is needed. Having done very large enterprise applications for very large enterprises with very large throughput, one of our old clients is one of the busiest stock exchanges in the world. We know what high volumes, high throughput is, not just from this client, but from many other clients. I cannot imagine where you will require the entire architecture to be microservices based. So I am okay with microservices to be added to an existing service-oriented architecture. You have a service-oriented architecture with 5 services, and you throw in 4 microservices in addition to handle 4 extremely tight latency, extremely high throughput operations. That's perfectly sensible. But an entire architecture, microservices? So where does this usually come from? These are the 3 things I have seen. One is, it's a pet project by an architect or a CTO who just loves the idea of having a microservices based architecture. Or it is a startup which wants to use all the buzzwords, data lake, AI, ML, microservices, name it, you have it. And they basically want to make their solution a buzzword rich architecture to attract trendy VC funds. And the third case is a really, really extreme application which I have never seen in large enterprise applications of various flavors which I have worked with. So let me give you this story that I was telling you about. So we were approached by this company which wanted to ask us to bid for a software project. So we inquired about their background and what they do and so on. It turns out that they were a startup somewhere, I will not tell you which region of the world. They were a startup and they were well on their way to commissioning the software development for their business. Broadly, they were in the fintech space and they would be doing some transaction processing. And their core team had 3 people, 2 of whom were business people, and the third one was their CTO, who had spent some 15-20 years in one of the very large global technology companies. So he was here as the technology member of the startup's core team. And when discussing their software requirements with us, they said that they would like a microservice-based architecture. We said, okay, great. So we were very impressed because if you're asking for a microservice architecture, it means you have the extreme high end of requirement for throughput and extremely low latency. So we were very thrilled that we were getting an opportunity to work on such high performance applications. So we asked them, what kind of transaction throughput or transaction frequency do you expect? So they said over 25,000. So when you've just heard them say that they want microservices and you hear the word the figure 25,000 transactions, you think at the very least 25,000 transactions a minute, if not 25,000 a second. So we said, wow, okay, 25,000 we just wanted to clear, 25,000 a month. And you can imagine our silence. 25,000 transactions a month. Okay, that's like 1,000 transactions a day, and they want microservices. So we have this problem. We try to be honest when we make a proposal. So we gave them a proposal and we said, we are suggesting that microservices will be overkill and a service-oriented architecture might be good. We personally thought monolithic would be fine. Their uptimes requirements, availability requirements were nothing to write home about, and they could be met with a monolithic architecture. But we said service-oriented, and if necessary, later on microservices could be introduced at a future date if they saw the kind of demands that cannot be met with an SOA. So they didn't give us the order, and we got the feeling that one of the primary reasons was that their CTO did not want to be told that microservices appeared to be inappropriate. So we don't know what to make of such people. So there, for such situations, I have used these words. An entire architecture using just microservices may be a pet project of a hobbyist architect or a hobbyist CTO, which means this is a hobby project for him. And there is nothing wrong with having hobbies, but logically, as a practitioner of architecture, it doesn't seem to fit. One of the common problems when using microservices is cross-service calls, synchronous cross-service calls. This is a big mistake. Synchronizing or collaborating across microservices should not be done by synchronous calls from the front end. They should be done at the rear by using the enterprise service bus. Using asynchronous messaging, not synchronous calls, because the entire throughput advantage of high performance microservices is 80% lost when you start chaining microservices one after the other in a synchronous chain. So we have also seen those mistakes done, not in architectures we have personally worked on, but which we have read about. So the only situation where I can imagine you might land up with an architecture which you can then claim is completely microservices based end to end is a serverless architecture where you are using serverless computing like AWS Lambda. In that situation, where even there, if you are not using separate databases for each microservices, it is not a microservice architecture. If you have 100 AWS Lambda components, but they are all hitting a shared database, then it's not microservices. But that is the kind of benefit of doubt I can give you, that in some situations maybe you have pushed partly towards a full microservices architecture. Otherwise, the term microservices architecture simply doesn't make sense. So this is one of the popular buzzwords which I am sorry I had to pour some cold water over. So after this, now that we've reached the end of this episode, the next one we'll talk about actual use cases. We will pick up actual use cases of what people are doing, or rather what business challenges are thrown at architects and what are the options the architect has to address those powerful business challenges. Okay, so we'll go into actual case studies, not real case studies, but hypothetical ones picked from actual requirements we have seen from the NFRs of actual business applications. Once again, thank you for watching and see you next time. We'll have some more fun ready for you.